Hi, I'm Raymond, and in this video, I'll be presenting my EM3 video assignment. Euler's method works on a simple idea. If we don't know the true solution curve, which is this, we can approximate it using straight line steps based on the slope at each point. Here's my diagram. This curve represents the true unknown solution y of x. Say we're at a known starting point, x0, y0 at this point. The differential equation tells us the exact slope at this point. That's f of x0, y0. So instead of following the curve, which we can't calculate directly, we follow the straight tangent line for one small step, h, which is our step size, along the x-axis. Where that tangent line lands becomes our approximate next point. But notice it's slightly off from where the true curve actually is. That small gap is the error induced at every step. Now, let's derive the formula. The slope of a line is rise over run. So f of x0, y0 equals y1 minus y0 over x1 minus x0. Since x1 minus x0 is just our step size h, we rearrange. F of x0, y0 equals y1 minus y0 over h. Solving for y1 equals y0 plus h times f of x0, y0. Generalizing this for any step n gives us Euler's formula, which is here. Y sub n plus 1 equals y sub n plus h times f of x sub n y sub n. This means we take our current y value at the step size times the slope at that point and we get our approximate y value. Repeat again and again until we trace out a path that stays relatively close to the curve. So next I'll be showing you my Excel. So now we use the step size of h of 0.1, which takes 10 steps to go from x equals 0 to x equals 1. I've set up a table with three key columns. The first is x sub n, increases by h each row from 0 up to 1. The second, y sub n, is my current approximation. Each row's value comes from the previous row's calculation, so the table builds on itself step by step. This is the next one. So the third column is the derivative f of x sub n, y sub n. For our equation, that's x squared plus 2 divided by y. This is the exact slope from the differential equation at that point. To move forward, I apply Euler's formula directly. Y sub n plus 1 equals y sub n plus h times the slope. I take my current y, add h times the slope, and that becomes the starting y for the next row. Repeating this 10 times approximately gives me 2.4026. Now I'll be showing you the general solution and checking against it. Our equation is separable. Y dy equals x squared plus 2 dx. Integrating both sides gives y squared over 2 equals x cubed over 3 plus 2x. Plus c, using y of 0 equals 1, we find c equals to 0.5. Substituting x equals 1 and solving gives us an exact value of y of 1, approximately equal to 3.805. Comparing the two, the absolute error is about 0.0222, a relative error under 1%. This makes sense because Euler's method uses straight line steps to approximate a curve, so it's not exact. So some error is expected. A smaller